So hello everybody, my name is Juan. I'm a software engineer at Pure Storage. I work in the performance benchmarking system team. Basically, we just make sure that our product is performing as expected on every iteration of our software. So today I'm going to talk about a specific service. I'm going to walk you through the milestones of this service and how it has grown, how it started when the company was still a startup, and how it is now that the company has hundreds of customers. So basically, through this talk, I'm gonna start with a brief introduction to the service. I'm gonna, as I said, I'll show you the architecture, how it was before, how it is today, how KEDA we're using KEDA to properly scale our service. Then I'll show you some charts, and at the end, the challenges that we're still having. Full disclosure, I'm no Kubernetes expert. I'm just here to tell you about my experience and also, hopefully, hear from you if you have some ideas how to do things better. So, Perfworker is a service that generates performance reports from customer appliances logs. The reason why this service is so important is that in a normal scenario, you have customers, they have an issue, and they come to you and they say, explain, and then you, as the provider, you have to go with them through the whole issue and hopefully find a solution. What Pure Storage wanted is avoid this whole situation and have a service that would tell you, okay, the performance of this specific appliance is having, it's showing that there will most likely be an issue. In this way, before there is an issue, we contact the customer if it's necessary, or we directly take action to fix it. How does Perfworker work? Let me just show you the graph. It's better here. So we have an S3 bucket where all the appliances every hour are phone-homing logs. These logs get stored in an S3 bucket. Once all the logs are completely stored, we trigger a notification, AWS SNS. Then this notification gets stored as a message in our queue, SQS, and we had some EC2 instances running Perfworker, which was basically consuming the messages from the queue. This is the initial look of our service. Smile for the picture with the worst infrastructure. Great. Okay, so. As I said, this was the architecture back when the company was still small. But as we were growing, we started seeing some recurring issues. As it was explained before, every time we had a higher load than usual, then an engineer would have to go scale up the EC2 instances, which was super painful and time-consuming. Also, not only you have to wait, but you also have you get you're on call, you get the alert, and then you have to wait all this time until the engineer actually goes. So yeah, there are some delays. Also, you are scaling up, and then you have to wait until the queue comes back to normal. So that means that there will be some time when you're overutilizing or underutilizing your resources. That leads to a lot of money being burned, or back then, observability was just a nightmare. If you have a bug in your service and you're trying to figure out what's happening, then in the EC2 instance, you're just like you have to go on the EC2 instances or use a watch cloud to navigate all these logs, try to find the specific process that was processing this message, and hopefully, you will figure out what the traceback is and debug it from there. So also you have to account some time for maintenance, like have a maintenance window. there was no really like monitoring other than the CloudWatch alert once the queue was growing. The performance of this service was not tracked. When I say performance, is basically how many messages we're getting, how many performance reports we're generating, like that percentage. And the service reliability wasn't something that we could basically agree on. We didn't have a defined SLA. Yeah. So yeah, there is autoscaling in EC2, right? You can just have some EC2 group autoscaling, and yeah, it will work. You will save the time that the engineer needs to go and scale up and down. So yeah, we did that, and then we found different new challenges, which is good, right? New challenges means that you're going forward, hopefully. So we were scaling up based on two metrics, which is basically like the most common metrics that you're scaling, right? CPU and memory. But the problem with these two metrics is that they are lagging indicators, right? If you start scaling up because the memory is like on, I don't know, 80%, it means that you are already like your load's already too high. Like same with CPU. If it's at 100%, you already you are scaling up once the problem is there already after the fact. Also, yeah, like limited metric options, you don't have so much flexibility. Most of the cases, you're just CPU or memory, and also you have to go through all the AWS scaling for the scaling groups, yeah, the policy, sorry. So the next milestone was the containerization. So the CI/CD pipeline before was just something like some Terraform and like some local testing. It was not something like, it was not structured. When we introduced the containerization, the pipeline, the CI/CD pipeline changed dramatically, not only for our team, but in general in the company. Now we implemented basically, we push our code, we have a PR, this code gets merged, we get some GitHub actions triggered that build the artifact gets uploaded to Artifactory, then we use some Spinnaker to actually deploy the Helm charts that we create on our Kubernetes cluster. So yeah, that sounds great. We have some Docker and we have some isolation, great. So this is how it looked like after, right? Pretty much all the changes is now instead of EC2 instances, we have the Kubernetes cluster with all our pods. So initially, we just have a deployment. We will have just an amount of replicas, again, just constant amount of replicas that will always be on. And just after doing this, we figure out, okay, there is HPA, horizontal pod autoscaler, let's do that. So we kind of did like a similar scaling approach as we had in EC2. So yeah, like our deployment pipeline was much easier, just basically pushing and you have your codes in production. We have some isolation, security, portability, all the benefits from having a containerized application. Also, we introduced like Datadog and Graylog, which later on became Elastic and the whole ELK stack. But yeah, so Datadog now allowed us to keep track of some metrics that we couldn't before. So this is what I was saying before about the performance of the service. Now, using a Kubernetes agents for Datadog, we could actually send these metrics, like if there is a traceback, what type of traceback is it? Just add, like count how many of these specific errors we're having, and yeah, show them in a graph. Or I have this many messages received, and these many performance reports generated. Give me a percentage of how efficient or how well this service is doing. So yeah. So time saved, which means that developer could use their time for like better tasks. and simplify the whole DevOps pipelines. Still, there were some challenges with just the HPA, which means still like when you get a Kubernetes cluster and you start using it, you need to learn about Kubernetes, the whole how to set it up, how to configure everything around it, and luckily for us, we have a specific team that does all the infrastructure stuff. So they just provide it to the rest of the company. But still, you need a person, at least one person in each team that knows a bit about Kubernetes and how things work. I am that person in my team, and that's the reason why I'm here. But yeah, so there is a learning curve there. Again, we were having the reactive scaling that I was talking before. Then you have the initial setup maintenance. This means doing all the Helm charts, understanding how the deployments work, all the containers, the pods, and so on. And still the resource management. So here's where Kubernetes event-driven autoscaling comes in. KEDA, which now you all know about. I'm just going to skip through some things. But basically, KEDA helps, first of all, the best advantage of KEDA is that it doesn't introduce any external dependency. It uses all the native Kubernetes functionality, all the features native from Kubernetes. So yeah, it also helps you automatically scale on pretty much every cloud native metric that you have out there. I'm gonna just leave this for a second. I mentioned just here a few, but there are 7 scalers available right now. You can find pretty much everything here. You have Azure, GCP, all the main at least. So in our case, this was great because now we have a queue, and we can scale up on depending on the size of that queue. Oh, sorry. Yeah. Okay. Yeah. So okay. Other features as well. As it was mentioned before, KEDA allows you to scale to 0, which is great in terms of it saves you a lot of money because you can just sometimes you have a service that doesn't need to run all the time. Just insert, if I don't have messages in my queue, why do I need to process anything or have something pulling that there is nothing, right? So I can scale down to 0, and I don't need to pay for any of those resources. Also, there are pretty much you can configure the scaling behavior as you want. You have cooldown time periods, which means that you can wait certain amount of time before you start killing some pods after you scale up. You can also scale based on how many pods you have right now. So for example, if you have 10 pods and you want to, there was a trigger and you wanted to scale only 10% more, you can have 11, and then as it grows, then you will have you will add 1 pod, then as it grows, it will increase more pods. These are scenarios that can fit for sure most of the applications out there. And yeah, I mentioned already, yeah, it's designed for Kubernetes, right? So there are 2 main specifications. I took this from the Kubernetes, from the KEDA documentation. There is the scale object, which basically will fit most of the cases. This is where all the, when you want to auto-scale a deployment or stateful set or some custom resource, this is what you're going to use. I'm going to show here a bit of how the code looks or the Helm looks. Basically, okay, this is big, but this is the important part. Oh yeah, definitely. Yeah, so basically, yeah, here the main things are the kind. Basically, you will just tell it, okay, I want my deployment to be auto-scaled, and this is the service that this is the name of the resource that I want to auto-scale. And later on, you can define the most important part is the triggers, which is triggers, yeah. So, okay. There is Okay, let me just try to SQS. Yeah. So in case of AWS SQS, you can have something like okay, let me make it bigger again. Yep. So in case of AWS SQS, you can have something like this. So you just define the details of your resource or your AWS SQS. This can be done with, as I said before, there are 70 scalers out there, which are just triggers. You can set many of these triggers, and then you can use the metrics that these services provide. In case of Perfworker, we use the queue size, basically the messages available, to scale our deployment. That means that if I have 0 messages in my queue, I will have 0 pods pulling messages. If I have 10, then I will have a proportional amount of pods and so on, right? There is also a scale job. So scale job is great, of course, for jobs. But in our case, we have another service that does the same that Perfworker does, but for internal appliances. And there, we recently started using scale job. Basically, what a job is in Kubernetes, for those that don't know, is something that runs once and it's completed, and that's it. So, and you can have some history of the few last jobs that failed, or the history of the last few jobs that were completed. So it's great for things that you just need to run once. And what I did here is that I introduced, so for each message, I will have one job being executed, and then I will like the advantages of doing it like this is I will have just one pod addressing one message from the queue, which helps me or saves me a lot of time when debugging an issue. In the past, I just have a monolithic piece of code that like it's constantly pulling everything in the same pod, is pulling multiple messages. So it's trickier to find the specific pod that was managing specific message. And once you find the pod, then it's tricky to find the specific logs that are coming from that specific process that was processing that message, basically. And yeah, here, like, I'm gonna show you, there is some Datadog charts here. This is basically, first I'm gonna show you the SQS. This is in the last day. So you can see that the relay, and this graph is basically how many pods I have out there, like desired amount and how many are actually running. So you can see, if I do it quickly, you can see the correlation here. So there is no delay, like there is no waiting for an engineer to like scale up or scale down something. It's something that it happens almost immediately. And in this case, this is defined by the scaling behavior, which actually, let me show you. So yeah, you can also find it here. Yeah, scaling modifier, no, advanced behavior, yeah. So here in behavior, you can set up how you want not only how you want to scale down, but also how you want to scale up. So yeah, I showed you already that, great. So yeah, like still, like after using KEDA, it solved pretty much all the challenges that we were looking to solve, but there is still, like, you have to like put some effort into learning about how KEDA integrates in Kubernetes, how the agents are working, and so on. So there is still some operational complexity there, and also it takes some effort to initially set it up or understand how things work. So guys, here's my LinkedIn. If you want to talk about something later on, or if you have some suggestions or ideas. If not, I will, yeah, let's. I did not get paid to come here by my company, but this was the template.
Okay, it's time for questions. First one is, can you schedule any Kubernetes resource type? For example, Carpenter, node pool, or does it need to be something with replicas like STS or deployment?
So, I cannot answer this question 100% sure, but it can, if you have a custom resource, or I don't know what type of resource you're talking about, like you cannot scale. I don't think you cannot scale nodes based on this. You have like Carpenter. In my case, I use AWS. Yes, sure.
Hi. So my use case for this would be we have some reserved resources. So it is cheaper for us when we have low normal traffic to use normal on-demand instances in AWS, but during the peak times for some tasks, I would like to use spot instances, which are cheaper. So right now what we do, we have a cron job that basically swaps node pool definitions from on-demand to spot. So I'm just wondering if I can use KEDA to do this, maybe based on our CPU usage or something.
I don't think so. I don't think KEDA is able to. Maybe. Okay. No. Oh, okay. Yeah. So yeah, the short answer is no. But I cannot tell you 100% I'm correct, but most likely no. Also, you make me remember one of the there was a funny story here. Once I first deployed the newly KEDA-based autoscaling Kubernetes approach, the day after, I was paged because finally I didn't set a resource limit on the resources that were autoscaled. So Perfworker was actually starving other deployments in the same cluster. There was, of course, a full postmortem. I learned a bunch with this escalation. But most importantly, after that, I started using node groups to properly, like we have a reserve node pool for just Perfworker, so we won't go there starving other deployments. So.
I will just complement the answer from Juan. The answer was correct. KEDA cannot scale your nodes. It's just scaling your pods, so deployment, stateful set, or like jobs. But what you can do in your case, for example, you just have you can have like two exactly the same deployments, like of your application. Just one will have constraints to be scheduled on the spot instances, and you can configure KEDA just to target like these two deployments. So one will be, let's say, scaled maximum, I don't know, to 10 pods, and other can be scaled like to 100 pods. So when you will have like a increase of traffic or spikes in CPU, whatever, it will start scaling the second deployment, you know, which will be scheduled on the spot instances or preemptables.
Yeah, this is correct. What was mentioned. Actually, we are planning, or what you can target with KEDA is actually any custom resource that implements scale sub resource. Is a specific type in Kubernetes, basically, and then you can define any object, and if you fulfill these specific requirements, you can target it with KEDA. So, for example, the same way you can target Argo rollouts or other resources. And for the specific question about node pool, we are considering adding some kind of capabilities like that to KEDA, so to basically target different resources than just pods. So this might be solved in the quite near future.
Just for your information, the guy who replies, he's Zbigniew, he's the maintainer of the KEDA, so it's our special host. So you can feel free to ask him even in the networking part. So just go on.
I know it. It's mine. Yep. Okay, second question. Can you configure out for triggers with IRSA? Can each data source use its own service account, or do you need one KEDA GODSA?
So I guess like you need to define a default AWS role here, but in each you can override this configuration, right? You can just I don't remember exactly what the property is, but in each configuration you can say, okay, the role that you need to assume is this, and you can override it basically.
You can have a cluster role, which will be shortly. You can have a good God SA,
Yes.
like which will be like one cluster authentication, let's say, and you can reuse it in every single scaled object in your namespace, in any namespace. Or you can have like specified service account, like authenticator per namespace, so you can do however you want. KEDA is like amazing project. I really love it.
Yeah.
So,
Same. Thank you.
yeah, having one of the maintainers here is amazing.
Like in general, KEDA have like a service account where you need to provide a role with some policy for assuming, but at the same time, you can provide in trigger authentication a possibility for service for IRSA of KEDA to make an assume of role that is attached to service account of your some type of deployment or replica set or stateful set. And I agree with Yuri that for that reason KEDA is really awesome from that perspective.
So does that mean you can basically assume a role maybe in a different AWS account rather than going? Yeah. Cool.
Anyone else?
Going.
Did I get it right, or did I miss something that you are using only Datadog as your only data source for KEDA?
Okay, so Datadog is just a visualization, like when something happens, I go to Datadog to check what has happened. But for observability, we not only use Datadog, we have now Elastic as well. Basically, we are using Datadog as a legacy that we're trying to get rid because it's too expensive. And now we're embracing Elastic. That's it.
Okay, so you basically have a primary data source for your observability.
What, sorry?
Do you have only a single data source for your observability or your metrics to, you know, push the autoscaler to do something, or do you have some backup?
Our autoscaling is working with AWS SQS. So depending on the queue size, it will scale up or down. That's
Okay,
it.
maybe that's the question for Yuri. It was Yuri. Yuri, did you ever try to use some, you know, fallback option for Datadog, and how it worked?
So, like I said, we always were using at least 2 scalars. So we started using it even before KEDA. So in the horizontal pod autoscaler, you can specify, for example, CPU and then the external metric provider, which can be Datadog. And then HPA evaluates on how it should scale, first calculating one option, CPU, then like Datadog, let's say, and then which is higher, then it will use that amount of replicas. It was working fine, but there were teams like Surge, for example, when they wanted to use some GCP metrics, and because of that lag, that metrics which are fetched to the Datadog from GCP, for example, we couldn't do this efficiently. Now they do use, so we use like Datadog, CPU, plus Stackdriver, or like cloud monitoring. Some teams are using Datadog Grafana, CPU based. Some use cron. So for example, it can be Datadog cron plus CPU. So there are a variety of options, and it works like really cool.